another set of parameters called relationships, but that again is going to be a small number. 15, 20, not 300, okay? A small number of relationships necessary to make the master assembly update, reconfigure, shift whenever I put in the three parameters, length, width, height. The relationships are what adjusts everything out to where it needs to be. Okay? The last thing that, not the last thing, but the next thing that you do is you set up datum planes. You set up like station lines that represent different significant places along your vehicle. You set up axes. You set up key points. So you build this kind of skeletal structure that is going to be then propagated down to the subassemblies. In addition to these high-level kind of defining things, if there are some sketch objects, lines and arcs and other sketch geometry that you want to be the backbone, the skeletal frame of the human body, if we were modeling that, if you wanted that, you represent not a full-size rib with a cross-section, but you represent that curve that represents the center line of a rib. Okay? So you represent very simple, very basic lines and arcs, and you do it in a sketch-based environment at the assembly level. Once this geometry has been entered, then what you do is you reach up and you link the geometry to parameters, to relationships, to datum axes. If a datum moves, this sketch needs to shift over. And so you link these things together with the key parameters, relationships, and datums. Okay. After you get this all kind of connected and you think things should behave right, what you do is you test to see if it actually does. You change the length, you change the height, you change the width, and you watch what happens to your skeleton structure. If it doesn't update and it doesn't change in dimension and size, go in and fix it. Okay? So everybody, this is an all hands on deck kind of done activity, but it's done in an application share. So it can't be just one person in there kind of figuring it out. It really ought to be 2 or 3 people on your team, either sitting there watching the screen, talking about it. It really ought to be everybody is kind of in there discussing how do we hook it up, how do we work it, how do we configure it. And you build this single file with one person, one keyboard.
The only participant in the conference.
Nice. Thank you. And if everything updates right, you save the assembly. Okay? But it's done as a group activity. The next thing that you do is you go back inside of this master assembly, and what do you have to do? You have to then create your first subassembly. So you build a subassembly, you create it, and once you create your subassembly, what you do is the first thing that you do is you grab a collection of these planes and a collection of the axes, and you propagate it, you share it down to that subassembly. So the subassembly has for all intents and purposes, has kind of a duplicate image of what's sitting up at the master level. Okay. Once you've linked it up, the next thing that you do is you create parameters inside the subassembly, relationships, and you may add more lines and datums and things like that. And so the subassembly by itself has its own set of key parameters, relationships, and things.
So, for example, like we're doing the right rear wheel system, and that's our subassembly. So you're saying that we're taking a couple of the data and reference them into a new assembly file
Yes.
for the wheel,
Yes.
and then from those references we can build more things. And
You add additional parameters that are going to define kind of the diameter of the wheel, the width of the wheel. You're going to add parameters that control the things that are very specific to that, not so much where it's located. So it's going to get where it's located and some basic size information from up here, the assembly. It's going to pull that down, but it's going to have additional knowledge that you have to put into it to make it robust and updatable. In addition to that, what you do is you add some additional sketches, lines and arcs and whatever, that represent part of its local skeletal frame. So we're beginning to put more skeletal information, not way up here at the top so it's a flat file, but we're beginning to bring this down so we've got an elegant assembly tree structure. Once we do that, what we want to do is go into this subassembly, okay? And in the subassembly, we want to basically look at applying the parameters and the skeletal things. And then what we want to do is go through a testing phase. We want to test this locally. So it's local parameters that we had to bring in, not bring in, that we added. We want to give those parameters and watch what happens to this subassembly. If everything behaves right, we want to leave that subassembly, go into the master assembly, and what are we going to change in the master assembly? The length, width, height of the car, and we're going to watch to see if that subassembly moves where it needs to and sizes itself and updates. And all it is skeletal geometry. We save the subassembly if everything updates right. We go back and we do that for another subassembly. We go back and do that for another subassembly. So eventually we have maybe 6 subassemblies, and we can now, as a team, each one of us go into a subassembly, and what is the process going to be? We want to start taking parts of the subassembly and putting it into part 1. We want to take part of the subassembly and put it in part 2, part of the subassembly and put it in part 3, part of the subassembly in part 4, and that's all skeletal geometry. So that's what our next, from the master assembly, to create individual parts, or so either master or subassembly. So in the subassembly, we want to begin paring this down and putting it into individual parts. We will create some skeletal geometry in each part, some parameters, some relationships in each part that are very part specific. We will eventually add additional parameters and relationships. We'll do additional sketches. We will then apply the part parameters in the individual parts to make sure that they look and are hooked up correct. And then we begin testing a part. We locally test the part. Does it behave and update parametrically the way it should? We go all the way up to the assembly, and we change length, width, and height. And if those length, width, and heights are used by the parameters and relationships in the part, what's going to happen? Our individual part will update. Okay. The idea is it takes a lot of effort to have an overall elegant assembly structure, but if you get that set up, it's very easy to get people building parts very quickly, and as the parts get saved, what happens when you go into the master assembly? They just pop into place. So you'll have parts just kind of appearing all over the thing where they need to. Next week, when you open up the master assembly, you've got 10 more parts because those were modeled and they all pop into place. You open it up a little later and you get more. The only things that don't magically hook up are what? Kind of the purchase parts. The fasteners, screws, things like that. Those are kind of a bottom-up approach. You go in and place them where they need to. And so it's very difficult for them to update unless they're tied to parametric points. So the punchline is we want to have this thing update and morph totally as a vehicle by changing length, width, and height. We'll see some of you tomorrow and the rest of you on Friday. Or Thursday. See everybody on Thursday and then back on.